702.
The Naked Scientist.
Hello, Chris.
Hi, Zani. Anything from sort of COVID to chemistry today, isn't it? Whatever anyone wants to throw our way.
Yeah, right. Yes. But I was fascinated to see the story break earlier on today that a tiger at a New York Bronx zoo has tested positive for the new coronavirus.
The tiger's name is Nadia, we're told, and a whole bunch of other tigers have been tested as well. This kind of aligns with what we've got anecdotally. There was a cat from Belgium which also tested positive a couple of weeks ago now. Its owner had COVID and appears to have passed it to the cat. The cat doesn't appear to have been very unwell. The same thing happened with a dog. There's a Pomeranian dog in Hong Kong that got tested and was apparently positive over a number of days when they swabbed it. Again, wasn't clear that it was making the dog unwell. So the fact that this cat's got unwell and has COVID, I mean, there's two ways to interpret that. One is the cat's unwell for some other reason and it's got COVID, or the COVID is causing the cat to be unwell. And that's why these other battery of tests are really important. And this is a very important issue to solve because, of course, at the moment, we're locking down humans and advising us all where to go and who not to talk to and how to socially distance and so on to try to break the chain of transmission. But when people take their dogs and cats out and take them dog for a walk, or the cat goes running around the neighbourhood, no one patrols and controls where these animals go and who they talk to and who they rub whiskers with. So if they're capable of getting infected, they could act as vectors between households. And that's notwithstanding whether or not they're going to get ill with this. So it's really important because in terms of disease control, outbreak control, but also vaccine effectiveness, if we want to prioritise who we give vaccines to, then we could be ignoring this elephant in the room. It's not an elephant, it's a cat or a dog, but you get the point. And so it's very important that we get to the bottom of this quite promptly.
Right. So from the assertions that have been made, COVID came from an animal, right, into human beings. And now here it is infecting from humans to animals.
Yep.
So a cycle of sorts.
Yeah, that's right. We think that the origin is because it's 95% similar genetically to a bat coronavirus, but also has a chunk of a pangolin coronavirus in it. Scientists speculate that the natural host of this was probably a bat that passed an infection through a pangolin, and the pangolin then passed the infection into a person or back to a bat, which then gave a hybrid to a human. They're still trying to unpick that one, but there's definitely evidence of a pangolin contributing a part to it and a bat. And because both those animals were being traded, in the case of the pangolin, highly illegally because they're very endangered species, in the wet market in China, it looks like that's the most likely site for that jump to have occurred. And then one of those two animals then started to infect people, and then people began to infect people. And it's quite unusual, actually, for this to be a two-way street of a human infection acquired from an animal to then go back. But it's not impossible. These viruses have quite a broad repertoire of hosts that they can get into. And the coronaviruses as a family, a very big family of viruses, they can prey on a number of different species, ranging from bats and pangolins through to people. So it's not altogether surprising, but it's interesting that if this happens as efficiently as it appears to have done with this tiger, it's quite surprising we're not seeing more of it with domestic cats and dogs. Maybe we are, and we're missing it, and that's why we have to go and look.
Yeah, we'll look forward to developments of this story. Let's go to Poloso in Woodmead in the meantime. Hi, Poloso.
Hello, Azar. Hello, Chris.
Hello.
Hello,
I
Poloso.
want to find out, taste buds. Do animals taste food as much as we do? I mean, when you eat grass, you just eat the most gross stuff. Do they taste food or do you eat for survival?
That's amazing.
Okay.
I don't think we've
Good
ever been
question.
asked that. That's
Yeah.
fabulous. Thank you for asking such a really interesting question. I would speculate that, yes, animals do have a pretty well-honed sense of smell and taste. And the reason I'm saying this is because not all animals can throw up like we can. A rat, for example, cannot be sick. So if it eats something and it turns out to be bad news, the rat has to live with the consequences. And if that bad news is it's eaten something potentially lethal, it will die. So many animals are extremely good at smelling things and tasting things and spitting them out before they swallow them. So I would say, yes, animals do have an acutely tuned sense of taste and smell. Bear in mind, though, most of what we call taste is actually smell, because we've only got a small repertoire of things that we can really discriminate with our tongues. Most of what we call taste is actually the smell of the things we put in our mouths going up the back of your throat and docking with the olfactory epithelium, which is a sheet of tissue at the top of the nose where there are smell nerves, and those smell nerves detect the chemicals being boiled off from the things you put in your mouth. And because your brain associates what's in your mouth with that stimulus, it then calls it taste, but actually it's just smell. So I'd say yes, animals do have a very good sense of smell because they avoid putting the wrong kind of thing in their mouth and potentially harming themselves by using their noses to do that. And then if they do actually get something in their mouth they then decide is not good news, they spit that out too.
Okay. Puluso, thank you. Thanks for the great
Thank
question.
you so much.
Wonderful. Puluso in Woodmead. Next, we've got Cynthia in Sandringham. Hello, Cynthia.
Hello. Thanks very much. Hello to you and to Chris. I've just been reading that infectious diseases occur mainly as a result of a chance mutation. And I'm just questioning this thing, chance mutation. I mean, is there such a thing as chance? I was under the impression that, it's part of the fabric of life. Something happens and is followed automatically by something else. Things don't just happen by chance.
Really pertinent at the moment, isn't it, with what we're seeing with the coronavirus circulating? And the answer is that the vast majority of these new emerging diseases and infections come to us from the animal world. So what's happened is that the disease has come out of animals and got into people, and in the course of doing that sometimes the disease has had to change or mutate, which means alter its genetic information to make it a bit better at spreading in humans. But that's not a given. Sometimes it's already good enough in the animal and doesn't have to change very much to spread very efficiently in humans. But it's certainly a risk factor, and as human population grows, as we urbanise, as we invade virgin rainforests, for example, and encroach on the habitats and territories of other wild animals, it brings animals with their viruses into close contact with humans, facilitating the jump into us. And we do other things that also make this sort of thing more likely. We make a mess, we have rubbish tips and things, and that's how dengue emerged in the tropics about 50 years ago. We also knock down lots of trees and drain swamps and change the environment so that different animal species are selected for in that particular environment, which encourages more potential vectors of disease. So basically, these viruses probably already all exist out there in nature in one form or another, and we're just increasing the likelihood that they can make that jump from their natural host, an animal, into a human. And yes, along the way they may change their genetic code to make themselves more optimal at doing that, but it's not a given that they would have to. Sometimes they're already good enough.
702. The Naked Scientist.
It's 14 minutes to 3 o'clock. That's how much time we have left with Chris Smith, Dr. Chris Smith, the Naked Scientist, this afternoon. Sbusiso, you're in Berea. Hello.
Yes, Azam. I wanted to find out what's the Naked Scientist position on the issue of masks. Now that it's a grey area.
Yes, this has created a lot of airtime, and people have debated this in some detail. The UK stance on this, which is informed by the available scientific evidence and also ongoing data collected from what's happening in other countries, is that wearing a mask when you're not infected with this virus and you are not working as a healthcare professional is not helpful to you. And the reason for this is severalfold. One of them is that most of the masks that people are using, including masks that people are making at home, are not made of materials that will actually stop the virus going through. The other point is that they don't fit tightly onto the face, so they leave big gaps which the virus can creep in through. In other words, they leak. And also people are wearing a mask but not protecting their eyes, and the eyes are connected through to the nose, and that's where the virus wants to be. So anything that lands on your eyes can drain into your nose if it can't infect your eyes straight away, which we think this virus may even do. So that's another gaping gap in the armour if you just go and wear a mask. The other point to bear in mind is most of the transmissions from this occur, at least in the UK, we've got data on this, 80% of the time it's transmitting in the household unit. In other words, among families and among people you live with. And only a small minority of the time it's actually transmitting when people are out and about. And this is because of social distancing measures, for example. So the bottom line here is if you're observing the guidance on social distancing and not mixing with other people, no mass gatherings, that kind of thing, you're not interacting with other infected individuals, your chances of picking it up and being exposed to it are already very low. And most people don't wear a mask when they're with their family at home. So the one time when you might, even if you were going to get any protection, you're not protected. So therefore, there's not much benefit in doing this.
Thank you.
That's Busiso in Berea. We've got Clive in Midrand next. Hello, Clive.
Yes, I have, and the doctor. I just want to find out, it's coronavirus. Is it like mumps or chickenpox? Meaning, if you've had it and recovered, is there a chance that you might get it again, or does the body develop
Immunity.
becomes immune to it? Yeah.
Right. Well, thank you, Clive. Chris?
Hi, Clive. We're investigating this actively at the moment because it's a very important question from the perspective of a vaccine. There's not a lot of point in making a vaccine against this if people can't make a lifelong or at least a long-term immunity to it. So people are actively pursuing this subject. For the moment, the jury's out. But we do know that when you have it and fight it off, you do produce a protective immune response, including the production of antibodies that are capable of neutralising the infection for at least a period of time afterwards. There is evidence with some coronavirus infections, because this is a big family of viruses, so what goes for one might apply to others, but equally might not. There's evidence from some coronaviruses that the immunity we get may be short-lived. So it could be that you catch it, you mount an immune response, you fight it off, you're protected for a while, but then you become vulnerable again. On the other hand, it might be like, exactly as you say, mumps or measles, for example. When you've had that, you then produce a lifelong protective immune response, which defends you for years to come. And scientists are actually doing the experiments at the moment, both looking at people who've been naturally infected with this new coronavirus, but also experimental animals that they're challenging with the virus, and then following how their immune system responds to it in order to learn the answer to this. And it is a very important question, because if we make a vaccine, we want to know what likely response people are going to make to that vaccine, and therefore how likely we're going to need to keep repeating the vaccine, or whether or not this is going to be something we do once.
Yes, I see that you answered one of the questions Mautle had asked us on Twitter and tagged you in it, saying, can we conclusively agree that it's airborne?
Yeah, he tweeted at Naked Scientists, and I did ping a message back saying these coronaviruses grow in your nose, throat, and very well in the lung tissue. And because we breathe, we're therefore breathing out clouds of vapour, and in that vapour are droplets of moisture, and in those droplets of moisture can be virus particles. And this is the main way these viruses spread, we believe, at the moment. So when a person coughs and splutters, they blow out a cloud of respiratory droplets full of thousands to millions of these virus particles, which are really tiny, and they're going to hover in the air for an extended period of time. And then a person who walks into that cloud and breathes it in could end up with those droplets, and then ultimately those virus particles on the parts of their nose, throat and lungs that the virus needs to in order to infect, and therefore they could pick up the infection. So yes, the main route of transmission, we believe, is through respiratory routes, but also because the particles that go in the air, what goes up must come down, ultimately they can land on surfaces, for instance computer keyboards, desks, door handles and so on. And if you come along and touch those surfaces, you could pick up some of the virus particles, and if you then transfer your hand, touch your eyes, nose or your mouth, you could move the virus to where it needs to go, to the eyes, nose and mouth, in order to infect you, which is where the hand washing guidance comes in as well. It's very important to make sure that you minimise that secondary route of spread.
Right. Laurel's calling us from Fourways. Hello, Laurel.
Hello, good afternoon. I just wanted to ask Chris if can the virus be spread through urine? If you sit on a toilet and it's not wiped properly, can it be spread that way?
Scientists have been looking at this because in the original SARS back in 2002 to 2003, it was discovered that that transmission through the sewage system was an important means of transmitting this agent. So they went looking. It looks like this virus can be shed in faeces, and in fact a significant number of people who present with infection also have symptoms of nausea and sometimes diarrhoea, which would go along with the fact that we think there are receptors that the virus uses to infect cells in the intestines as well as in the lungs. Now that means that it can spread through faeces, but we don't think it's going to spread in urine. And the reason for that is that when a person has the infection, unless they have very, very severe infections spilling over into the bloodstream, there's not a lot of virus in the blood, and therefore there's not going to be a lot of virus in urine anyway. It doesn't seem to have what we call a tropism towards kidney tissue, but it does in the intestine. So therefore it is possible that what goes down the loo could pass on the infection, but it won't be urine, it'll be faeces.
Ah, okay. Thank you so much for that question, Laura.
Yes, thank you.
Thank you. Here's an SMS. It says, I had TB 10 years ago. With that, I lost about 20 to 30% lung function. Does this put me under the list of high-risk people?
Well, it could do. TB causes a range of lung problems. It can lead to damage that's irreversible to lung tissue and fibrosis, which can rob a person of lung capacity. And as a result, if you're already starting from a position where your lungs are not optimal, if you lose a bit more lung function, it could make you even worse. And therefore, because you're starting from a lower point, you're already a bit more vulnerable. The other question is, well, with the TB, did you have any other diseases or infections that might make other infections worse? So it would be important to rule out the fact of an underlying immune problem as well, just to check, because people with an immune problem are going to be, by definition, more vulnerable to any infection, including this new coronavirus. So it's not a given just because you had TB and recovered from it that you're at high risk. But if it has done lasting damage to the lung and you do normally succumb badly to respiratory infections in winter, like when the flu comes and that kind of thing, that might be a red light. It might be a warning sign to you. And any underlying immune disorder as well would definitely be worth checking into, because, TB often has housemates, if you know what I mean, and it's important to rule that out to make sure there's not some other problem like HIV underneath as well.
So, Chris, with the COVID-19 also doing damage to lungs, what about the recovery? So when someone does emerge as negative, they've recovered, has it also destroyed the lungs, or are the lungs able to regenerate and renew themselves?
The range of symptoms people are presenting with is very broad, and it ranges from people having very trivial illness and almost no symptoms at all, if some people even say they had no symptoms, through to people who end up in intensive care with respiratory failure, and they end up with a condition which is called ARDS, which is acute respiratory distress syndrome. And this is where you get inflammation and damage to lung tissue. The air spaces in the lungs fill up with fluid and inflammatory material. So you reduce lung surface, you increase the distance between where the blood is that needs the oxygen and where the air is that's got the oxygen to give to the blood, which means a person's robbed of oxygen, so their whole body's suffering a lack of oxygen. But that inflammation in the lung can ultimately translate into permanent, for want of a better phrase, scarring in the lung tissue in the form of fibrosis. So you get stiffer lungs than you should have. And sometimes, as a consequence of treating a person in intensive care and having to ventilate them to save their lives, this can do additional damage to the lung and make those sorts of problems worse. So there are cases of people who've been through this and they unfortunately had permanent changes to their respiratory system. So they never got back to quite what they had before. And that is always a risk factor with any of these very invasive type illnesses or interventions that we have to make to save lives. But, it's certainly not a given that a person will have this, maybe get a bit unwell and then bounce back. Some people do get very seriously unwell, and unfortunately, in the course of becoming very unwell, they develop serious problems that are lifelong with their lungs.
Yeah, that's new clarity, new sobering. Let's go to David in Midrand. Hello, David.
Hi, good afternoon. Thank you so much for the points you've made on masks, Doctor. But just to add to the issue, if we wear them, even if we don't know whether we have the infection or not, it will minimize the spread of droplets. And in particular, if we cough or sneeze, where it said you could project over 6 meters a droplet. Surely that is part of the other side of the issue. And the Czech Republic have gone this route. And so far I think it's the Czech Republic, they seem to have had significant success in containing the condition.
Yeah, although one has to be careful about saying, well, there's been this intervention and it has caused this to happen. We don't know because, for instance, Sweden doesn't have a lockdown at all and they haven't got the same sort of case density that other countries do. So it is not as easy as cause and effect. You do masks, you get this. You don't do masks, you get that. One has to be careful about attaching significance to a coincidence. But your point is a good one, that if you are highly infectious and you're coughing and spluttering and you put a mask in the way, that might help to reduce the spread to other people. But again, it comes down to the point I made, which is that if you're observing social distancing, you're working from home to the greatest extent possible, you're avoiding contact with other people who are not in your household unit, actually that shouldn't be an issue anyway. Therefore, the amount of benefit you buy from telling everyone to wear a mask is not enormous.
We've got Shaheem asking a question that I'm seeing become quite popular. Even Kerry Hilson put it out a few weeks ago. Hi, Shaheem.
Hi, I wanted to find out about this 5G Wi-Fi. Is it dangerous for humans?
Well, people have actually been burning down masks in some countries because they were under the impression that these masks are in some way linked to this COVID-19 outbreak. This is fake news. please don't believe this information. 5G does not spread coronavirus infection. It does not damage your immune system, and nor does home Wi-Fi. It's a conspiracy, really, against 5G, I think. People are putting this out there. There's no evidence whatsoever to support this stance. So please use the 5G network to make emergency calls. It's there to help you. Don't go and destroy it, because it is not linked to this disease. This disease is caused by a virus which cannot be transmitted over a 5G network. It is transmitted by hanging out with too many people who've got it.
There we go. One person wants to know whether it's present in semen.
Good question, and I don't know the answer, of course. That was the one that caught us out with Ebola. People hadn't expected that to happen with the Ebola outbreak in West Africa, and it turned out that that was a major route of spread in some cases. Again, for this one, I think it's probably low likelihood that that will be the case, because in a person who recovers uneventfully, there won't be much virus, if any, in the bloodstream, and therefore there won't be any of it getting into what makes semen. Therefore, there wouldn't be any in semen, so that probably wouldn't be the main route of transmission. But you can never say never in medicine, and someone needs to check into this to check.
All right. Thank you. What a note to end it off on. Thank you, Chris.
Thanks, Susanna. See you soon.